So moving forward with our last presentation of the day, it is on fire safety testing of ICF wall construction, and it is going to be presented by two speakers, Shamim Rashid Sumar from NRMCA and Robert Scultorp, ICFMA. I'll just briefly introduce both of them. Ms. Rashid Sumar is a Senior Vice President of the National Ready-Mix Concrete Association in New York, leads efforts with National Building Code and Standards Organization to promote resilience and sustainability through non-combustible construction. She offers technical support on codes, standards, regulation, and legislation at all levels. With the Bachelor's in Fire Protection Engineering, she is a Fellow of the Society of Fire Protection Engineers and serves on the SFPE Board of Directors and SFPE Foundation Board of Governors. Additionally, she presides as President of the Alliances for Concrete Standard and plays key roles in various NFPA and ACI committees, along with the ICC Multi-Hazard Resilience for Residential Construction Committee. Welcome, Sham. Our co-speaker is Robert Scultorp. Sorry for the mispronunciation. He is the PE Engineering LEED certified and technical director of ICFMA and has been active in ICF sector of building products industry for over 25 years. Robert is a professional engineer licensed in the province of Ontario, Canada. He holds the designation of LEED AP. Robert represents ICFMA on the technical committees in the US and Canada. He is the past chairman of ACI Committee 560, Design and Construction with ICFs, and member of the Residential Concrete Committee 332. At ASTM, he is the chair of Task Group E06.21.20, which is responsible for standards E2634. Robert has experience with building construction, energy efficiency, and resilience. And with this, I hand over to both our speakers.
Okay, well, first of all, thank you for the opportunity to present this information. This is what we're going to cover today. I'm responsible for the first bullet, review of insulating concrete forms, and Shamim's going to cover the relevant standards and ICF performance tests. We're here for any questions. I just want to take a minute and discuss this cutaway of an ICF, a sample of an ICF wall. I know, talking with some of you that and recognizing faces in the audience, that you live in houses with ICF walls. Perhaps not all of you are that familiar with them. So, this, starting from the inside surface out, this is a gypsum wall board which provides a thermal protection, thermal barrier to the EPS panel, which is next. And the ICF consists of the two EPS, expanded polystyrene panels on either side, and they're held in position by the cross ties, which typically are plastic. Polypropylene is the most commonly used material. There's concrete on the inside with rebar, and then on the outside you'll put whatever cladding is the designer's desire to have on the outside. So that's the description from the interior surface to the exterior surface. When the wall is constructed, the contractor, these ICF forms come, they're typically, not always, 4 feet long, 16 inches high, and they stack up just like giant Lego blocks. And just like giant Lego blocks with your children, if there's a problem the way the first course is stacked, it only grows as you go up the wall. So you have to be careful that they're stacked properly. As you're stacking them up, as a contractor stacking them up, they place the rebar in, the horizontal rebar, and there are chairs to receive the horizontal rebar, and then the vertical rebar is installed as needed, as specified by the design. Then concrete is placed in the wall. There's the concrete, it's consolidated, and that's the ICF wall assembly. Because it's a concrete wall and the concrete provides a structural component, it's a non-combustible wall with a combustible component being the expanded polystyrene insulation and the plastic cross ties. The benefits of this system, just briefly, are you've got the wall is completed, you've got the concrete, the structural component, you've already got the insulation needed in the wall assembly in place. This component of the cross ties provides an opportunity for attachment for furring strips that you can attach the interior finish to, and in residential construction you usually attach the exterior finish to, the furring strips on the outside. In commercial construction you frequently have to come back to the concrete and anchor it to the concrete. So you've got the concrete reinforced structural wall, you've got the insulation, the furring strips, and then the concrete wall is frequently recognized as the air barrier. So you've got a 6-inch thick air barrier, and in most climatic conditions, that is also recognized as the water barrier, but not always, and that depends on the local climatic conditions. So sometimes a water-resistant barrier is needed on the exterior surface. So that's it. The other thing I want to make, because when I go to the next slide it'll pop up, is this is termed a flat ICF wall because the two surfaces of the concrete are flat and parallel to each other. Earlier in the development of ICFs there were different configurations that were called waffle walls or screen grid walls. And that this work that we are doing and the association that I'm representing only represent flat wall ICF walls. So, get it to move forward. There we go. So this is the standard that's referenced in the IBC, ASTM E2634, and it's for flat insulating concrete forms. And so that's the standard. All the product that we're using in this testing program complies and is compliant with that standard. Thank you.
Thanks, Robert. There's a new section of the IBC that appears in IBC 2024 and 2 application. If you went to this section in the definition, this section will be entitled water resistant barriers. So in edition as part of this as a result of some concerns related to external walls that's about to be new and requirements these requirements were always there, not appear in this section. Chapter 14 being exterior walls, and section 14.2 being performance of external walls. So this section states that external walls is under the type 5 restriction must comply, and it's really during most of the sections that follow, and each of those sections goes through different components of exterior walls. It says whether those sections were to acceptance criteria. So showing walls and components that are true assembly must be tested. The 2024 edition was just published, and there was some work done right here. It says 40 feet. That actually does not appear in the final version of the text. If you this text there, this is the impetus for some towards the end of the presentation. So, and to things and ICF. Before I do that, I'm going to go through all of the things steps are in progress for ICF. into some more detail. So this is what the ignition resistance test looks like. And this is just to see the standard test region. Any external assemblies using a source. And so this is a flux. So here's where our test duration of 20 minutes, and the test is considered a failure if there is any sustained flaring. So this really determines ignition of an external burn. This is typically specified also systems. And the surface welding test that I mentioned, ASTM, this is also as the standard type test. This is a repetitive test, so this is a long horizontal surface burn where materials are installed in a horizontal configuration. The calibration is done based on testing of reinforced calibration materials that has flames zeroing. Testing of these calibration material that flames so expanded slightly and ICFs that mostly apply to pass this test instead of a flames point index that is 25 decimal. We should not perform this. Terrible Esperanto, but we should perform this. I won't go too much into detail about ASTM 19. It was covered quite a bit in previous presentations. I will just mention this is a test. It's a taste for some structure. It's representative from this test to see that this is really is determined based on this test is necessarily a real power really performed. It is a test. And you saw this time temperature curve here. As I mentioned, these ratings should not be providing in relationship to how strict specific. It's probably over 85 decibels, but basically that was that you actually saw kind of a section view of this furnace, and that was actually an actual test of ICF. So based on that ASTM 119 test, you can actually go into the UL online certifications directory, and you will find certificate test listings for ICF since it's rated this particular example like directly from the entry erased the manufacturing was in this particular one. It's a rating for 2 hours if it has a concrete thickness of 4 inches, and it has a flaring of 6 inches. So ICF assemblies do carry a fire resistance rating. Again, I'm not sure an example. It varies with the manufacturing listing, typically for a 4-inch concrete 2 hours, 6-inch vary between 4 inches and 8-inch based on 4 hours. We do also have ICFs that are for construction. 2 to 3 hours system. did want to go over, this is not a required test, but I wanted to talk a little bit about how ICFs in explosion types of these. And so there was some ice resistance testing in 2003. This was done in preparation force protection demonstration that took place at one base. And it was really used to demonstrate the plasma resistance of ICFs. So the testing involved these ICF reaction boxes that were constructed. You can see in the picture right. These are the reaction boxes right here. And they were subjected to blasts from this, which was providing a 50-pound charge of material-grade TNT. And these reaction boxes were placed at various distances, from 6 feet to 40 feet. It's the acceptance criteria that the military uses other military personnel inside the structure, so in this case inside the ICF structure, survived the blast. And the testing outcomes, there were limited damage observed to the concrete structure. And the reason this is the case is because the PS4 absorbs energy from the shock waves, and it dissipates energy over time, and it also motions the concrete. And I particularly wanted to show you this testing because we also have a real case study where we saw this somewhat in action. This is a case study of an ICF concrete apartment building that survived constant fire. This was in East Harlem, New York City, in 2014, and there was actually a gas explosion that occurred next door. That gas explosion had destroyed 2 apartment buildings. It caused 4 neighboring properties to be evacuated, and it also shattered buildings that were located 3 blocks away. So, obviously, this had impact buildings and households affected because they weren't necessarily right in that location. There were 8 deaths, 70 injuries, it's a large response, 250 emergency personnel. This was actually in the news because the utility was found responsible for $3 million worth of damages. But in all of that tragedy, the ICF concrete building that was right next to the building that the explosion survived lasted and was able to make repairs. And these are some pictures. Some pictures on the left is from 2013. This is the ICF building here. And this is the explosion. You can see this is right after. So this is the ICF building. This is the explosion. Shortly after 2015. This is the standing. This is the explosion. This one. The New York Department of Buildings engineers report noted that this building survived even though it was inches. The explosion occurred. The only damage that was to this building, I mentioned that there was debris. I made one mention. There was debris that occurred obviously when this building exploded. And actually some of the debris is along Harlem. The subway is actually above grade, so it has elevated trees. So there was actually so much debris that it landed on those measured trees, and so surface was suspended until for most of the day. But that debris, it also landed on the floor. And so when the fire service came to as part of their fire operations, there was a lot of damage to the floor. So the repairs that was nutritions. So we've kind of gone through all of these tests that have been done for ICF construction to date. The missing piece is this test, the NFPA 285 test, which is really looking at international that I went through earlier is from commercial fires from tower. I also mentioned fires. These are fires where the fire is spliced just very rapid spreads because of this type of violence. So the 285 test is used test method for evaluation of fire propagation characteristics. Again, external assemblies. This is a test. Containing coastal systems. So Germany is this is a picture of the test of this. I've cut this off of the section, so probably have to hear was about 18 feet tall and 13 feet high. This is fire. It is occurring on the inside of the building, so you can see there's a wall on the inside, and it's a test. It's a survey of fires. It's external burns. Instead of simulating this rate of exposure to the exterior. The test duration is 30 minutes, and failure is considered to have occurred if the temperature of the exterior wall is there. If the temperature reaches 1,000 degrees Fahrenheit at any point, it's also looking at flame spread. So if the flames reach a height of 10 feet, so if the flames spread up to, let's say, about here, that's considered a failure. And if the flames spread on the exterior goes past this 5 foot, it's also considered a failure. So this is the one test that is not being completed for the ICF construction. We're very lucky to be supported by NICS as well as the ACI Foundation endorsement from the ACI 560 and ACI 216 committees. And we have started working on our current testing, which is investigating 285 compliance for ICF construction. And you see here, these are the frames in which we are building our ICF walls. We are challenged because the wall is assembly test. The picture of the ICF section that Robert went through. Our walls are a little bit different than most other exterior walls because we have a thickness of concrete plus we have thickness of foam. So it actually has to be built on this frame, and the weight of our assembly is typically heavier than a lot of the assemblies that we tested. So these frames are our frames. They are specifically constructed for ICF walls assemblies. They have a 15-ton capacity to accommodate the weight of our frames. And this is our test plan. So we have preliminary. We have 2 tests that we're starting with. This is the section of test 1, which is ICF wall with ECM line. You can see the dimensions here. Worst case scenario to start with. So we have worst case scenario for us is the thickest concrete and the thickest foam. So we have 4 inches of concrete. We have 2 and 3/4 inches. Our EPS test. These are some draft details of what details of the whole thing are going to like. Dissertation, flooding, and how it is a connection between resources and air. Specific test. Our second test is with. And we assume that this test is going to be better for obvious reasons than the ICF. We have the same things as well, and the same things. This is detail. So this is a of testing that's been done to date for ICF and testing that we are in progress. Some results to share.